Alright guys, what's up? It's Mr. Lynch coming back at you with another great math video. Today, representations of a function. So we're going to learn different ways to draw and show that something is a function of something else. Now the first thing, where am I going with this? What am I doing? As always guys, hit like, make sure you subscribe, make sure you are ringing that notification bell so you can see these videos as soon as they come out. Get that first like, get that first comment. You guys know you want to. Alright, so now, back to what I was saying. One of the ways we can show that something is a function is what's called a mapping. And a mapping is a representation of a function that helps us better understand non-numeric relations. And a relation is just, we're saying something is related to something else. So like, circumference to ring size, state to team. That is a relation. So, we're going to look at these in the mappings below and then decide if it's a function or not. So, if our input is circumference and our output is ring size, is this a function? Well, we've got an input going to one output. We've got one output, one output, one output. Is it a function? Yes, it's a function. Because each input has only one output. And if it only has one output, then we know that it has to be a function. Looking over here, an input is the state where you live and the team you root for in college football. So Utah votes for the Cougars and the Utes. I don't know how to pronounce it. I'm just going to go with Ute because that's how they pronounce it in Australia. And there's a certain kind of car called a Ute. An Ute, sorry. It's an Ute. All right. And then Nevada also votes for the Utes. In Arizona, the Sun Devils. Well, look at Utah. How many outputs does it have? Utah split. Some people in Utah go for the Cougars. Some go for the Utes. So is this a function? No. Utah has two outputs. And because it has two outputs, we cannot say that it's a function. So let's write the ordered pairs that go with this. So again, we're just going to do, alright, actually I shouldn't say again, we haven't looked at this yet. But when we write the ordered pairs that correspond with a problem, we do these super cool curly bracket. Actually, that's a terrible curly bracket. There we go, curly bracket. And you put your parenthesis. And we go input then output. So 14.1, 3, comma, 14.9. Oops, shouldn't have ended that. 14.9, 4, 15.7, and 5, 16.5, and 6. And then to end it, we do another curly bracket. And the commas in there are just to separate and say that these ordered pairs are different. I'll let you guys write the ordered pairs for the state. But remember, it's just what does the input go to? What's the output of the input? What's the output of the input? And what's the output of the input? So city a student lives in and the high school they go to. Well, right off the bat, we can see that Salt Lake City gets split up into 3 different high schools. So this one input has 3 outputs. Provo has 2 outputs. So is it a function? No. Salt Lake City has 3 outputs. And Provo has 2. Guys, remember the definition of a function. The definition of a function is that each input, or each x, has at most one output. And we say at most because it can have 0. But it must have at most 1. That's the most it can have. So that is not a function. Age to level of basketball teams, or baseball team. Wow, I can't speak. So at age 5, they play t-ball. At age 6, they play t-ball. 7 is minor. 8 is minor. 9 is junior. 10 is junior. Now, before you guys answer this, because I'm pretty sure you guys are going to say, no, this isn't a function. Think about it. Does each input have only one output? Does 5 go to t-ball or minor? If you're 5, can you play junior? No. Each age has a very specific baseball level that it goes with. So yes, this is a function. Each age has one league, or one level. So because each age only has one level of baseball they can play, it must be a function. Is this going all right so far? I'm really hoping so, because functions are one of my favorite things, and I really want you guys to get this. Okay. So there's so many different ways to represent a relation or a function. Like all the equations we've been working with have been functions. You guys have been working with functions forever now. So let's look at the story. So a candle is 27 centimeters high and burns at 3 centimeters per hour. So an equation that models this relation is C equals 27 minus 3h, where C is the height of the candle and h is the number of hours. So that's easy. Let's start off with just our table. So at 0 hours, we haven't even lit it yet. It's 27 centimeters high. After 1 hour, it has burned 3 centimeters. So we drop down to 24. After another hour, it drops down to 21. And then a third hour, we're down at 18. A fourth hour, we reach 15 centimeters. So let's map this. So hours, we'll go 0, 1, 2, 3, 4. And our heights of 27, 24, 21, 18, 15. So now, to map this, we just draw from 0 to the corresponding height. So 0 goes to 27, 1 goes to 24, 2 goes to 21, 3 goes to 18, and 4 goes to 15. Graphing this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're going to have to go by twos. So 30, 28, 26, 24, 22, 20, 18, 16, 14, 12, 10, 8, 6, 4, 2. And we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so our height at 0 hours is 27. So we're going to be right here, right in between 26 and 28. After 1 hour, we're down at 24. 2 hours, we're down at 21, so halfway between 22 and 20. 3 hours, we're at 18. 4 hours, we're at 15. 5 hours, we're at 12. 6 hours, we're down at 9. 7 hours, we're down at 6. 8 hours, we're down at 3. 9 hours is 0. So now I want you guys to write out the set of ordered pairs. Now, you don't have to use all of them. Trust me, that's a lot. So we'll go 0, 27, 1, 24, 2, 21, 3, 18, and I'm going to cut it off there. But it continues on, so I'm going to put some dots to say it continues. But guys, the ordered pairs are just the ordered pairs we use in the graph, or the ordered pairs we see in the table, or the ordered pairs from our mapping. And you guys have done tables. You guys know how to do tables. You guys have done graphs. You know how to do graphs. The only new things here are the mapping and the set of ordered pairs. Other than that, You guys have done all of this. So don't think about it as something new and overcomplicate it, but instead just think about it as it's something different. It's what you've done before, but we're adding a little something to it. All right, it's not different, it's not new. We're just adding in a few extra steps. So is the height of the candle a function of the amount of time it's been burning? So is our output, if our input is hours, and our output is height, I cannot spell to save my life. Is this a function? Does each hour have its own specific height that it's associated with if it's burning? Yeah, of course it is. Of course this is a function. We can't have, after 2 hours of burning, it's got to be at 21 inches. It can't be at 15 inches and 21 inches, or 21 centimeters and 15 centimeters. That'd be ridiculous. It can't be two different heights at the exact same time. So clearly, this must be a function. Ooh, look at this mapping. So we got a mapping. So let's fill out our table. So -1 is our first x value, and that goes to 0. 0 goes to 1, but 0 also goes to -1. 1 goes to 2, but 1 also goes to -2. 2 goes to 3, and 2 also goes to -3. So is this a function? Just right off the bat, is this a function? Does each input have at most one output? Or does each input have multiple outputs? I'll let you guys think about that, but let's graph this. So at -1, we're at 0. At 0, we are at 1 and -1. At 1, we are at 2 and -2. At 2, we are at 3 and -3. Yeah, I'm thinking this is not a function, because if we look, 1's going up to 2, but 1's also going down to -2. Look at this. Look at that. We've got 2 points for an input. Got 2 outputs. So the reason I'm drawing these lines in here is because we have what's called the vertical line test. If you can draw a vertical line and go through more than one point, it can't be a function. And clearly, we're drawing a completely vertical line here, and we're going through more than one point. So this cannot be a function. And I'll let you guys do the set of order pairs. No. 3 inputs have 2 outputs. You can't have more than one output and be considered a function. Functions can have 0 outputs for an input, or they can have 1 output for an input. Anything above that, and it's not a function. Ooh, Discovery Place Preschool has gathered data on the age of each student in years and the height. So we've got this data here. Is this a function? Is height a function of age? No. No. Inputs have multiple outputs. I mean, do you guys see this? At 2, we go through 1, 2, 3, 4. We go through 4 dots just right there. We go through 5 dots here, and we go through 4 here. This can't be a function. All right, let's check this next one. So now they're just going to give us a relation, and we have to determine, is it a function or not? Let's check if an input is in here twice. So we've got 30 seems like the lowest, so we've got another 30 here. The output is 2, and the output is 4. So no, this is not a function. 30 has 2 outputs. $11, is this a function? No. I mean, look at this. No matter where I draw a line, we're hitting 2 points. And we draw a line there, we could draw a line there, we could draw a line here. This is called the vertical line test. Just telling you guys again. But if I can draw a vertical line and hit 2 points, it is not a function. X equals 2. Is each input going to have a single output? I got to think about this. So if it's x equals, this is a vertical line. So no matter what, my x value is 2. So let's write this out in ordered pairs. So I'm going to have 2, 5. I'm going to have 2, 6. I'm going to have 2, 7. I'm going to have 2, 8. Yeah, we have the same input and completely different outputs. So, no. This is a vertical line. Ooh, this will be fun. Let's put this in a slope-intercept form. So to put it in slope-intercept, I need to get the 6y by itself. So I'm going to subtract 3x from both sides to get 6y equals negative 3x plus 18. Now to get the y by itself, I just divide by 6. So I get y equals 3 divided by 6 is 1/2, but one of them is negative, so it's negative 1/2 x, plus 18 divided by 6 is 3. This is a linear equation, and we could draw this. It's a line that has a slope of 1/2 and a y-intercept of 3. Well, since it's a linear equation, and we can graph this and know exactly what it looks like, each input will have at most one output. So yes, this is a function. This is a linear function. All right, you guys tell me, A, how many outputs does it have? A has one output. B, well, B can go to 88 or 87, so that's 2. Nope, not a function. Nope. B has 2. B has 2 outputs. It's a no-go. So this is asking if percentage is a function of letter. Because percent is our output, letters are input. It's always output is a function of input. Now, it wants us to flip that. Is the letter grade a function of the percent? So let's redraw this mapping. So we need to flip them. So we got 95, 88, 87, and 66. We got A, B, and D. So A and 95 go together. 88 goes with B. 87 goes with B. And 66 goes with D. Now, here's the question. Does each input have one and only one output? Well, let's write the ordered pairs. 95 is A. Okay, so far so good. 88 is B. Okay, our percents are different. We're good to go there. 87 is B. Our output is the same, but our inputs are different, so that's fine. And we get 66D. All of our inputs are different. So yes, this is a function. each input, the percent, has only one letter grade it's associated with. I mean, think about it. How terrible would that be if you have an 88% in a class and you have a B and a D at the same time? Doesn't make sense, right? If you have an 88%, you know you have a B. But if this weren't a function, then you would have a B and a D at the exact same time. Okay. Is time of day a function, is temperature a function of the time of day? So is it different temperatures at the same time of day? Nope, 8 a.m. 65 and only 65. Noon is only 70. 2 is only 75. 4 is only 80. And 7 is only 65. So yes, each input has only one output. But if we flip it, so if we look at it backwards, well, 65 is going to 7 and 65 is going to 8. That doesn't work. No. 65 has two outputs. All right, guys, I'll let you try the last one on your own. So that is it for this lesson, guys. As always, I hope you enjoyed the video. Make sure you hit like, make sure you subscribe, make sure you are ringing that notification bell so you can see these videos as soon as they come out. As always, guys, enjoy the math, and we'll see you soon.